Hello everyone. Today I have come up with a chapter from ICSE 10th Chemistry. The name of the chapter is mole concept. This chapter is based on few laws and numericals based on those laws. Children find it very difficult, and on request today I am making the lecture series for mole concept. So let us find out what all topics are included in this chapter and then start with the numericals. My name is 𝑰𝑪𝑬𝑴 and you are watching 𝑰𝑪𝑤𝑴 classes. So the topics in this chapter is, first topic is Gay Lussac's law. So we have the law and then the numericals based on the law. Avogadro's law. Third is percentage composition. Fourth is empirical formula and molecular formula, and fifth is reaction stoichiometry. So we have numericals based on all these topics. Now today I'll be starting with the first topic, that is Gay Lussac's law. The law is very simple. I'm not going into the law. You can just see the law and mug up the law. They can ask you the statement for the law and it has to be written as per the book. So I'm not going to the law. I'm just directly starting with the numericals because you find numericals more difficult. So let's start with the numericals based on Gay Lussac's law. So let me take the first numerical. So the first question is, 450 centimeter cube of carbon monoxide and 200 centimeter cube of oxygen are mixed together and ignited. Calculate the composition of the resulting mixture. So for this kind of a question, first of all, we need to write a balanced chemical equation. So let us see what all things are reacting here. First is carbon monoxide and oxygen. These two things are reacting together. So let us write a balanced chemical equation. 2CO plus O2 gives us 2CO2. This is a balanced chemical equation. You can see 2 carbon here, 2 carbon this side. 2 plus 2 oxygen, 4 oxygens, 2 to the 4 oxygen. So it is balanced chemical equation. Now they are saying 450 centimeter cube of carbon monoxide. So this is given 450 centimeter cube, and 200 centimeter cube of oxygen. This is given, and we need to find out the resulting mixture. So the resulting mixture means how much product is formed, that we need to find out, and also if there is any unconsumed reactant. So that also will be there in the resultant mixture, right? So let us see the ratio between carbon monoxide and oxygen from the balanced chemical equation is 2:1, right? So if this is 450, as per the ratio, oxygen has to be half of it. That means half of 450 is 225. But we do not have 225 centimeter cube of oxygen. So let us take oxygen instead of taking carbon monoxide. So if oxygen is 200 centimeter cube given, then how much will be the carbon monoxide which will be reacting with this much of oxygen? Let us find it out. Cross multiply. It will be x into 1 is equal to 2 into 200. Therefore, x is equal to 2 into 200. So, x will be is equal to 400 centimeter cube. We can directly do from here also. The ratio is 2:1. So, if this is 200, this will be double of it. That is 400. But the right way to do it is cross multiply and show. So, x is 400 centimeter cube. That means 400 centimeter cube of carbon monoxide will be reacting. But we have given 450 centimeter cube. That means 50 centimeter cube of carbon monoxide will be still unconsumed or unreacted carbon monoxide, which will be remaining in the resultant mixture. So write it down. Unconsumed carbon monoxide is equal to 450 minus 400, that is 15 centimeter cube. So this much carbon monoxide will be there in the resultant mixture. Also in the resultant mixture there will be some amount of product. So now let us find out how much product will be formed. So now I'll be taking the ratio between, I can take the ratio between oxygen and carbon dioxide, or between carbon monoxide and carbon dioxide. So let us take the ratio between oxygen and carbon dioxide. From the balanced chemical equation, you can see 1 volume of oxygen is producing 2 volumes of carbon dioxide. So it is 1:2. Now oxygen is 200 centimeter cube. So if this is 200 centimeter cube, how much will be the production of carbon dioxide? Again cross multiply. So you can see 1 into y is equal to 2 into 200. That means y is equal to 400 centimeter cube. That means how much carbon dioxide will be produced? 400 centimeter cube. So here you can write down carbon dioxide produced is equal to 400 centimeter cube. Anything else is there in the resultant mixture? No, because the entire oxygen has been consumed. The unconsumed carbon monoxide is 50 centimeter cube and the product which is formed is 400 centimeter cube. So the resultant mixture, so here we have to write, finally we have to write the composition of the resultant mixture is unconsumed carbon dioxide, that is 50 centimeter cube, and carbon monoxide, unconsumed carbon monoxide, that is 50 centimeter cube, and carbon dioxide is 400 centimeter cube. So this is the composition of the resultant mixture. Now the second sum, it is saying that 1 volume of nitrogen combines with 1 volume of oxygen to form 2 volumes of nitric oxide. So basically here they have already given you the balanced chemical equation. You just have to write it in a proper manner. So they are saying 1 volume of nitrogen, take 1 volume of nitrogen, and 1 volume of oxygen, so take 1 volume of oxygen, and it is producing 2 volumes of nitric oxide. The formula for nitric oxide is NO, and it is producing 2 volumes of nitric oxide. They are asking calculate the amount of each reactant, that means nitrogen and oxygen, the amount of nitrogen and oxygen to produce 250 milliliter of nitric oxide. This is given 250 milliliter. So let us see. So this is asked and this is given. So we need to take the ratio between what is asked and what is given. So let us first take nitrogen and NO. So the ratio between nitrogen and nitric oxide from the balanced chemical equation is 1:2. That means 1 volume of nitrogen is required to produce 2 volumes of NO. So now if NO is 250 milliliter, how much will be the volume of nitrogen? So let it be X, cross multiply. So it is 2x is equal to 250 or x is equal to 125 milliliter. So that means 125 milliliter of nitrogen is required. Similarly, we have to find out the amount of oxygen. So now we are going to take this and this, the ratio between oxygen and nitric oxide, because this is asked and this is given. So we have to always take the ratio from the balanced chemical equation for the species which is given and which is asked. Okay. So now for oxygen, we'll be taking oxygen is to nitric oxide. From the balanced chemical equation, we can see 1 volume of oxygen produces 2 volumes of nitric oxide. So take it 1:2. So if nitric oxide is 250 milliliter, oxygen will be how much? Oxygen is Y. Cross multiply, so it will be 2y is equal to 250 or y is equal to 125 milliliter. We can easily see from here only that the ratio is 1:2. So if this is 250, this will be half of it. But this is a right way to show the sum. So what they are asking, calculate the amount of each reactant. So here you have to write amount of nitrogen required is 125 milliliter and amount of oxygen required is 125 milliliter, or you can write amount of nitrogen and oxygen required is 125 milliliter each. Let us proceed to the next question, question number 3. What volume of oxygen would be required to burn completely 400 milliliter of acetylene? The formula for acetylene is given C2H2. Also calculate the volume of carbon dioxide formed. So here you need to understand the reaction is happening between acetylene and oxygen. So you need to burn acetylene. Acetylene is C2H2 and you need oxygen for burning it. And since it is completely, they are saying it is completely burned, we need to understand that the product of complete combustion is always carbon dioxide and water. Okay, so here in the product side we will be getting carbon dioxide plus water. So this is the reaction. Now we need to balance it. Here this side we have 2 carbon, so make it 2 carbon over here. Once we made it 2 carbon, oxygen has become 2 2s are 4 plus 1, 5 oxygen. We have to make 5 oxygen over here. So if I do 5 by 2, 2 gets cancelled and it is 5 oxygen. But we cannot keep the, in the balancing part we cannot keep fraction. So to remove this fraction we will multiply the entire equation by 2. So it will be 2C2H2 plus 5O2 gives us 4CO2 plus 2H2O. Now let us see whether the reaction is balanced or not. Here it is 2 2s are 4 carbon, here this is 4 carbon, hydrogen is 2 2 4, here hydrogen is 2 2 4, oxygen is 5 2 10, 4 2s 8 plus 2 10. So it is a balanced chemical equation. Now we are saying a 400 milliliter of acetylene is given and they are asking for what volume of oxygen would be required, and this is given 400 milliliter. So now let us see, from the balanced chemical equation 2 volumes of acetylene requires 5 volumes of oxygen. So let us take the ratio between acetylene and oxygen. Since this is given, the volume of this is given and this is asked, so we are taking the ratio of these 2 species from the balanced chemical equation. Okay, so the ratio is 2:5. If this is 400 milliliter, how much will be the volume of oxygen? Cross multiply, it is 2x is equal to 400 into 5. So x is equal to 400 into 5 divided by 2. This is getting cancelled. This is 1000 milliliter. That means 400 milliliter of acetylene requires 1000 milliliter of oxygen for complete combustion. Also they are asking calculate the volume of carbon dioxide formed. So again this is given and this is asked. So I will be taking the ratio between C2H2 and carbon dioxide because the volume of C2H2 is given and carbon dioxide is asked. So from the balanced chemical equation the ratio is 2:4. Here this is 400 milliliter. How much will be the carbon dioxide formed? Cross multiply again. 2y is equal to 4 into 400. So y is equal to 4 into 400 divided by 2. This is getting cancelled, 800 milliliter. So carbon dioxide formed is 800 milliliter. So we have to write the answer finally. That is, they are saying what volume of oxygen would be required. So in answer we'll write volume of oxygen required is 1000 milliliter. This is one of the answer. And calculate the volume of carbon dioxide formed. So volume of carbon dioxide formed is 800 milliliter. Question number 4. 3000 cc of oxygen was burnt with 600 cc of ethane. The formula for ethane is given C2H6. Calculate the volume of unused oxygen. That means I have already told that here oxygen is in surplus. It should be unused. So let us first write down a balanced chemical equation for the complete combustion of ethane. Your ethane is C2H6. It is reacting with oxygen. As I mentioned in the previous sum, that the product of complete combustion is always carbon dioxide and water. So on the product side we will be getting carbon dioxide and water. Now let us balance this chemical equation. Here you have C2. That means here we need to add, use 2 over here. Carbon has become 2. And now hydrogen is 6 over here. So make hydrogen 6. We are using 3 over here. Now see how many oxygen this side, 3 and 2 2s are 4. 4 plus 3, 7 oxygen. We need to have 7 oxygen. So we'll write 7 by 2. But again it is a fraction. So we have to multiply the entire equation by 2. So we get 2C2H6 plus 7O2. We get 4CO2 plus 6H2O. Now you can see each and every element in the left hand side and right hand side is perfectly balanced. So we got a balanced chemical equation. Now 300 cc of oxygen is 3000 cc of oxygen is given, which is in surplus. Surplus means it is in excess. And 600 cc of ethane is given. That means we need to see for 600 cc of ethane how much oxygen should be required. So from the balanced chemical equation, we'll be taking the ratio between ethane and oxygen. We can see 2 volumes of ethane. Here 2 volumes of ethane react with 7 volumes of oxygen. So the ratio between ethane and oxygen is 2:7. So if this is 600 cc, how much will be the oxygen? So cross multiply, we are getting 2x is equal to 7 into 600. So x is equal to 7 into 600 divided by 2. This is getting cancelled. So we are getting 2100 cc. That means 2100 cc of oxygen will be used. The question is calculate the volume of unused oxygen. We have put 3000 cc of oxygen and 2100 cc of oxygen is used. So the amount of unused oxygen is, we will write it here, volume of unused oxygen is equal to 3000 minus 2100, that is 900 cc. So this is your answer. 900 cc of oxygen is unused. So children, we will move on to the next question, that is question number 5 now. 60 cc of oxygen was added to 24 cc of carbon monoxide and the mixture is ignited. Now again, when say the mixture is ignited, that means you understand that it is a complete combustion taking place, right? And calculate the volume of oxygen used up and the volume of carbon dioxide formed. So let us first write down the balanced chemical equation. Here 60 cc of oxygen was added to 24 cc of carbon monoxide. That means here the reaction is happening between carbon monoxide and oxygen. So we will write a balanced chemical equation. 2CO plus O2 gives us 2CO2. Right? Now 60 cc of oxygen. This is given 60 cc and 24 cc of carbon monoxide. The mixture is ignited. Calculate the volume of oxygen used up. So we need to see how much oxygen is used up. Right? So let us take here from the balanced chemical equation, we can see 2 volume of carbon monoxide requires 1 volume of oxygen for the complete combustion. So let us take the ratio between carbon monoxide and oxygen. It is 2:1. That means if carbon monoxide is 24 cc, oxygen will be, suppose x. Cross multiply, we will have 2x is equal to 24 or x is equal to 12 cc. That means 24 cc of carbon monoxide requires 12 cc of oxygen. So how much oxygen is used up? 12 cc of oxygen is used up. Another thing is that the volume of carbon dioxide formed. So now we can take the ratio between carbon monoxide and carbon dioxide. CO is to CO2. We can see from 2 volumes of carbon monoxide, 2 volumes of carbon dioxide is formed. So the ratio is 2:2. So if this is 24 cc, how much this will be? We can easily find out from here, since the ratio is 2:2. If this is 24, this has to be also 24. But as I mentioned, this is the right way to do it. So 2y is equal to 24 into 2. So y is equal to 24 into 2 by 2. 2 gets cancelled. Y is equal to 24 cc. So in the answer, we are going to write it down that they are asking calculate the volume of oxygen used up. So here you have to write volume of oxygen used up is equal to 12 cc, that is this, and the volume of carbon dioxide formed. So volume of carbon dioxide formed is equal to 24 cc. So the question number 6 in front of you, 200 centimeter cube of carbon monoxide is mixed with 200 centimeter cube of oxygen at RT means room temperature, and ignited. Again, ignited means again the combustion reaction is taking place. Calculate the volume of carbon dioxide formed on cooling to RT and what other gas, if any, may also be present. That means we have to find out the composition of the resultant mixture. So let us write down the balanced chemical equation. It is the same as the previous question. 2CO plus O2 gives you 2CO2. So here this is given 200 centimeter cube. And even oxygen is given 200 centimeter cube. They are asking calculate the volume of carbon dioxide formed and if there is any other gas present, that is if any unreacted reactants are present here. Okay, so let us first take CO is to oxygen. Let us find it out how much oxygen will be required to burn 200 centimeter cube of carbon monoxide. Okay. So from the balanced chemical equation, we can see 2 volume of carbon monoxide requires 1 volume of oxygen. So the ratio is 2:1. So if this is 200 centimeter cube, how much will be the amount of oxygen? So it is 2x is equal to 200 or x is equal to 100 centimeter cube. That means 100 centimeter cube of oxygen is used up and another 100 centimeter cube of oxygen is still present. So the last part, what other gas, if any, may also be present. So there is oxygen present and how much? 100 centimeter cube. Okay. Now let us find out how much carbon dioxide is produced here. So now we are going to take the ratio between carbon monoxide and carbon dioxide because this is given and this is asked. So from the balanced chemical equation, we can see 2 volumes gives us 2 volume. So the ratio is 2:2. So if 200 centimeter cube this is, then what will be the amount of carbon dioxide? Cross multiply. 2y is equal to 2 into 200 or y is equal to 2 into 200 divided by 2. 2 gets cancelled, y is equal to 200 centimeter cube. So amount of carbon dioxide formed is 200 centimeter cube. So we should write the answer this way here. That is, they are saying calculate the volume of carbon dioxide formed. So we will write volume of carbon dioxide formed is equal to 200 centimeter cube. And the last part, what other gas, if any, may also be present? There is 100 centimeter cube of unreacted oxygen gas present. Now in question number 7, calculate the volume of oxygen required to burn completely a mixture of 22.4 dm cube of CH4 and 11.2 dm cube of hydrogen. So that means there is a mixture in a container. Suppose some amount of methane gas is there and some amount of hydrogen gas is there. And you have to burn both of them completely with the help of oxygen. That means there will be 2 reactions now. One is with methane plus oxygen, and another one will be hydrogen plus oxygen. So let us write down the 2 balanced chemical equation. First reaction I am writing with methane plus oxygen, and the product will be CO2 plus H2O. Let us balance this chemical equation. This is 4 hydrogen, so this is 4 hydrogen, 2 plus 2, 4 oxygen, so this is 2 O2. So the reaction is balanced now. Now this is first reaction, and the second reaction is hydrogen plus oxygen gives you H2O. So this is 2H2 plus O2 gives you 2H2. So I wrote both the balanced chemical equation. Now they are saying CH4 is how much given? 222.4 dm cube of CH4 is given. For that, how much oxygen is required? We need to find out. And hydrogen is given 11.2 dm cube. For that, how much oxygen is required? We need to find out. Okay. So now let us do it from the first equation. Suppose this is my first equation and this is my second equation. From here, CH4 is given and oxygen is asked. So we will be taking the ratio between CH4 and oxygen. So it is CH4 is to oxygen is 1:2. 1 volume of CH4 requires 2 volumes of oxygen over here. So if this is 22.4 dm cube, how much will be the value of oxygen? Cross multiply. So once we cross multiply, we get x is equal to 22.4 into 2, that is 44.8 dm cube. So from the first equation, for completely burning of CH4, oxygen required is 44.8. Now from here, hydrogen will take the ratio between hydrogen and oxygen because this is given and this is asked. The ratio from the balanced chemical equation is 2:1. If this is 11.2, how much oxygen is required? Cross multiply. So 2y is equal to 11.2 or y is equal to 11.2 divided by 2, that is 5.6 dm cube. Now, so they are asking what is the total volume of oxygen required? See the question, calculate the volume of oxygen required to burn completely a mixture. Now oxygen has to burn both the gases because both the gases are there in the mixture. So what is the total volume of oxygen required? That is 44.8 plus 5.6. We will add these two volumes. Okay. So the volume of oxygen required is equal to 44.8 and 5.6 dm cube. So what is the answer? Just take it out. 50.4 dm cube. 50.4 dmq. So how much oxygen, what is the volume of oxygen required? It is 50.4 dmq of oxygen required. Okay, now question number 8. Question number 8 says 200 milliliter of C2H4 is burnt in just sufficient air containing 20% of oxygen. As per the equation, C2H4 plus 3O2 gives you 2CO2 plus 2H2O. Calculate the resultant mixture composition. So the balanced chemical equation is already given to you. C2H4 plus 3O2 will give you 2CO2 plus 2H2O. You have been given 200 milliliter of C2H4 is burnt in just sufficient air. So in the reaction we can see C2H4 is reacting with oxygen. So from here we will find out how much oxygen is required to burn 200 milliliter of C2H4, and since 20% oxygen is present in air, considering 80% of nitrogen, we'll see how much air is there and then we'll find out the rest of the part, that is nitrogen. So let us see the ratio between C2H4 and oxygen, which is seen from the balanced chemical equation, is 1 volume of C2H4 reacts with 3 volumes of oxygen. So it is 1:3. That means to burn 200 milliliter of C2H4, how much oxygen is required? Let it be X. Cross multiply, X is equal to 600 milliliter. So we require 600 milliliter of oxygen. But here it is said that in just sufficient air. Now 600 milliliter of oxygen will be coming from how much air, that we need to see, because 20% oxygen is present in air. So we'll write that 20 milliliter of oxygen is present in 100 milliliter of air. That means for 600 milliliter of oxygen, how much air is required? It is 100 divided by 20 into 600. 0, 0 cancel, 2, 30. So it is 3000 milliliter of air will be required to get 600 milliliter of oxygen out of it. So that means the rest of the part will be nitrogen, because we are considering air is made up of two major gases, that is oxygen and nitrogen. So the volume of nitrogen in the resultant mixture, because that will be present in the resultant mixture, that is 3000 minus 600, that is 2400 milliliter. So in the resultant mixture, one of the gas will be present, that is nitrogen. Other two gases will be carbon dioxide and water vapor. Now let us see how much carbon dioxide will be produced. So now we are going to take the ratio between C2H4 and carbon dioxide. We can see this is 1 mole and we are getting 2 mole from 1 mole of C2H4. So if this is 200 milliliter, how much will be the carbon dioxide? So it is Y is equal to, we can cross multiply, Y is equal to 2 into 200, that is 400 milliliter. That means how much carbon dioxide will be formed? 400 milliliter. Therefore, volume of carbon dioxide produced is equal to 400 milliliter. So this gas even will be present in the resultant mixture. And what else? The rest of the part will be water vapor. So let us see how much water vapor will be produced. Now we are going to take the ratio between C2H4 and water vapor. So 1 mole produces 2 moles of water vapor. So 200 milliliter produces how much? So let us take it as Z. So Z is equal to again 200 into 2, that is 400 milliliter. So volume of, therefore volume of H2O produced will be is equal to 400 milliliter. So understand, when they say resultant mixture, the resultant mixture will not only contain the product, but it will also contain the unreacted reactants as well. So since in the reactant side we have taken air, first of all we saw to burn 200 milliliter of C2H4, how much oxygen is required? We got it 600 milliliter of oxygen is required. Now for 600 milliliter of oxygen, how much air we have to provide? Because we are doing the reaction in air. So we need 3000 milliliter of air. Now air doesn't only contain oxygen, but it contains nitrogen also, 80% nitrogen. So if 3000 milliliter of air is there in the reaction mixture, how much nitrogen will be present? 3000 minus 600, that is 2400 milliliter of nitrogen will be present. So in the resultant mixture, this nitrogen will be present along with the product, that is carbon dioxide and water. So let us start with the 9th question now. A mixture of 10 centimeter cube of carbon monoxide, 60 centimeter cube of hydrogen and 20 cc, that is centimeter cube again, of CH4 are mixed with 750 centimeter cube of air containing 20% of oxygen and ignited. Calculate the composition of the resultant mixture on cooling it to RT. So that means there are three gases now. One is carbon monoxide. This is reacted with oxygen because all these three gases are mixed with 750 centimeter cube of air, which contains 20% of oxygen. So first we need to show the reaction between carbon monoxide and oxygen. That gives you this equation. Next is hydrogen plus oxygen, so H2 plus O2 gives you 2H2O. I'm just writing the balanced chemical equation. And the third one is methane gas, so that is your CH4 plus O2 gives you CO2 plus H2O. So this will be 2H2O, this will be 2O2. All the three balanced chemical equation I wrote. Now they are saying calculate the composition of the resultant mixture on cooling it to RT. So resultant mixture means again, as I told you, that the products as well as if there is any unconsumed, this thing is there, unconsumed reactants are there. So carbon monoxide you have 10 centimeter cube and hydrogen you have 60 centimeter cube and CH4 you have 25 centimeter cube. And these are mixed with 750 centimeter cube of air which contains 20% of oxygen. So let us see in 750 centimeter cube of air how much oxygen is present. So volume of oxygen in 750 centimeter cube of air is equal to 20% of 750. 0, 0 cancel, 0, 0 cancel. So that is 150. 750 into 2 is 150 centimeter cube. That means altogether you have only 150 centimeter cube of oxygen. Now let us see how much oxygen is required over here. So first case में the ratio between CO is to oxygen is 2:1. So if CO is 10 centimeter cube, oxygen will be how much? So from here we get X is equal to 2X is equal to 10. So X is equal to 5 centimeter cube. So from the first reaction we got oxygen required is 5 centimeter cube. From the second one, the ratio between hydrogen and oxygen is 2:1. 2:1. Hydrogen is 60 centimeter cube. So if this is 60 centimeter cube, how much is oxygen over here? So you are getting 2y is equal to 60 or y is equal to 30 centimeter cube. So we need 30 centimeter cube of oxygen for the second reaction. Similarly, let us do the third one. The ratio between CH4 and oxygen is 1:2. So this is 1:2. CH4 is 25 centimeter cube. Oxygen, let it be Z. So here we are getting Z is equal to 25 into 2, that is 50 centimeter cube. That means total oxygen required for all the three reactions is 50 plus 30, that's 80, 80 plus 5, that is 85. And total oxygen you have 150, that means how much oxygen is unreacted? 150 minus 85. So that will be remaining in the resultant mixture. Along with that we'll be getting carbon dioxide, water and here this also, right? So let us, where should I write? Let us write it here. For the first reaction, CO is to CO2. I will be taking it here, making it little short. So the ratio between CO is to CO2 from the first equation 1:2. So if this is 10 centimeter cube, how much will be carbon dioxide? Let it be A. Okay, so cross multiply, it will be A is equal to 20 centimeter cube. So how much carbon dioxide is there? 20 centimeter cube of carbon dioxide. So I'm just writing it here so that we can summarize it. Carbon dioxide is 20 centimeter cube from the first equation. Let me rub this because I don't require anymore this one. Now from the second one, hydrogen is to water vapor. Hydrogen is to water vapor is 2:2. So if hydrogen is 60 centimeter cube, water vapor will be how much? B. So cross multiply and very clearly you will get B is equal to 60 centimeter cube. That means from the second equation we are getting water vapor is 60 centimeter cube. Okay. Now let us see the third one. CH4 is to CO2. CH4 is to CO2 is 1:1. 1:1. So if this is 25 centimeter cube, CO2 will be how much? Let it be C. So C is equal to again 25 centimeter cube. So from here also we are getting carbon dioxide, that is carbon dioxide is equal to 25 centimeter cube, right? So total carbon dioxide will be 25 plus 20, 45 centimeter cube. We are going to do it later on. And also water, let us see how much water will be here. So let me take CH4 is to water. So CH4 is to water, the ratio is 1:2. 1:2. If this is 25 centimeter cube, water will be, suppose D. So D will be is equal to 50 centimeter cube. So water vapor is equal to here, H2O is equal to 50 centimeter cube. Okay. So from here also, we got water vapor somewhere else also. This is carbon dioxide, this is carbon dioxide. Water vapor we are getting from here. And here also we got water vapor, that is 60 centimeter cube. Yes. Now let us summarize how much, calculate the composition of the resultant mixture. Let me rub this. Okay. So total oxygen required here, just 5, 50 and 30. I am rubbing this part now. There is no place actually. So total oxygen required is equal to 50 plus 30 plus 5, that is 85 centimeter cube. Okay? So unreacted oxygen is 150 minus 85, that is 65 centimeter cube. So in the resultant mixture there will be 65 centimeter cube of unreacted oxygen. Acha, how much total carbon dioxide? Total carbon dioxide produced is equal to 20 plus 25, that is 45 centimeter cube. So this also will be there. And how much is water vapor? So total H2O produced is equal to, this side it is 50 and here it is 60. So 110 centimeter cube. Anything else is there? No. So now finally we have to write down the answer. So in the answer we'll write, the composition of the resultant mixture is 85 centimeter cube of oxygen plus 65 centimeter cube of carbon dioxide. 65 centimeter cube of unreacted oxygen, this one, plus 45 centimeter cube of carbon dioxide and plus 110 centimeter cube of water vapor. So this is the composition of the resultant mixture. Now let us proceed towards the last question of today's lecture, that is question number 10, which says 20 milliliter of each of oxygen and hydrogen and 10 milliliter of carbon monoxide are exploded in an enclosure. What do you mean by that? Suppose this is an enclosure. Here you have 20 milliliter of each of oxygen and hydrogen. That means you have 20 milliliter of hydrogen here, 20 milliliter of oxygen here and 10 milliliter of carbon monoxide. Okay, 10 milliliter of carbon monoxide are exploded. What will be the volume and composition of the gases when they are cooled at room temperature? That means you have to see how, so very clearly oxygen will be reacting with hydrogen and oxygen will be reacting with carbon monoxide, and there will be some products, and we have to see what is the composition of the resultant mixture once they are cooled at room temperature. So let us write down the balanced chemical equation. The first equation is 2H2 plus O2 gives us 2H2O. This is the first equation, and the second equation is 2CO plus O2 gives us 2CO2. We have done this number of times in the previous questions. So we have written the balanced chemical equation for both the reactions. Okay. Now, so for the first one, 20 milliliter of oxygen is there and 20 milliliter of hydrogen is there. So we need to see the ratio between hydrogen and oxygen is 2:1. So if this is 20 milliliter, oxygen, how much oxygen will be reacting? It is 2x is equal to 20 or x is equal to 10 milliliter. That means only 10 milliliter of oxygen will be reacting in this case. Okay. Now, how much water vapor will be produced? We can take the ratio between H2 and H2O. It is 2:2. So if this is 20 milliliter, very clearly this is also 20 milliliter. So Y is equal to, we can cross multiply and we get 20 milliliter of water vapor. So once we cool down the reaction mixture, we will be getting 20 milliliter of water vapor as well. Now let us see here, CO is to oxygen, the ratio is again 2 is to 1. If 10 milliliter of CO is there, how much oxygen it will be? Let it be A. Cross multiply, 2A is equal to 10 or A is equal to 5 milliliter. That means 5 milliliter of oxygen will be reacting with CO also. So total we have put 20 milliliter of oxygen, where 10 milliliter is reacting in this case and 5 milliliter is reacting in this reaction. So total 15 milliliter is used up. So unreacted oxygen will be 5 milliliter. So that will do later on. And also we will see the ratio between CO and CO2 is 2 is to 2. So if this is 10 milliliter, CO2 will be suppose B, and very clearly B is equal to, we are getting 10 milliliter. So how much CO2 is produced? CO2 is 10 milliliter. Okay. How much oxygen here? It is 5 milliliter oxygen is used up here. How much H2O is produced? It is 20 milliliter. And how much oxygen is here? It is 10 milliliter. So total oxygen used up is 10 plus 5, 15. So unused oxygen. Therefore unused oxygen is 20 minus 10 plus 5. That is 20 minus 15. That is 5 milliliter of oxygen. Right? And the resultant mixture also contains H2O 20 milliliter and carbon dioxide 10 milliliter. Therefore, the composition of the resultant mixture is unused oxygen, that is 5 milliliter, volume of carbon dioxide, that is 10 milliliter, and volume of water vapor, that is 20 milliliter. So that's all. So today we have done 10 questions from Gay Lussac's law. All the questions has to be solved this way only. So first of all, we need to write a balanced chemical equation, and then we have to find out the ratio between the given quantity and what is asked, and then accordingly we'll find out the answer. So in the next video, I will be coming up with Avogadro's law, numericals based on Avogadro's law. Thank you so much. Stay tuned.